So guys, today I want you to do an experiment on latent heat, to find the latent heat of vaporization of water. To do that, we're going to do the following. You're going to go into your kitchen and take a kettle and put in some water. Okay, I'm not going to put in too much, just a little bit because I actually want it to boil quite quickly. And I forgot something. I'm first going to measure the mass of the kitchen, not of the kitchen, of the kettle plus the water inside. It doesn't matter how much water is in the kettle, it just matters that I record the total mass that I have now, and I'm going to record how much mass I have in total afterwards. And the difference will be the water turned into steam. So I have here 1,215 grams. I'm going to record this here on the board. So the mass before is 1,215 grams. So now I can turn this on. And now I can wait a little bit. I'm going to use a timer on my phone in a moment when it starts boiling. I don't want to start the timer just yet. I'll wait until it actually boils. So my timer is ready now, but I'm not going to start it. Important, leave the lid open because we actually want to boil the water away. If you close the lid, then the steam can't escape, and of course you know that the kettle will turn off when the lid is closed. Okay, now it's actually starting to boil properly, and that's where I'm starting my timer.
And I'm going to let this boil now for about a minute and then record the difference in the mass. Now you see there's quite a bit of steam coming out here.
Okay, and now I have 60 seconds. I can just turn this, well, I'm just closing the lid, so, well, a little bit of steam still escapes, and I am now on 1,164. 1,164 grams, so this is my mass now. That means now, du kannst ein bisschen näher kommen. Now you can actually calculate the latent heat of vaporization of water. Just like before, we did Q equals ml, and we said that power is equal to Q over T, so therefore Q is equal to P times T. The power on my kettle here, be careful not to spill it and burn yourself as you do this. The power here, you might not be able to read this, but this is actually 2,000 to 2,400. Again, I take the middle value of this, so 2,200 watts, as we talked about before. So here Q equals 2,200 watts times 60. That was my time, 1 minute. I need to record it in seconds. And I'm going to equate that to the mass times the latent heat of vaporization. If I get my calculator to do this, it's my calculator, I get 60 times 2,200, that is 132,000 joules. That is equal to the mass that turned from water into steam. And that is, of course, the difference that I have here. I'll call it delta M so that you know it's the change in mass. It's the mass that now became steam. 1,215 minus 1,164, and that gives me 51 grams. You see, that is not very much mass in terms of kilograms, because I need kilograms here as my unit. I divide by 1,000, kilo, 1,000, and I get 0.051 kilograms. So Q equals ml. So I can write Q equals ml. Here is my Q, so I have 132,000 equals 0.051 times L. So L is equal to 132,000 divided by 0.051, and that gives me 2,588,235. I'll ignore what's after the decimal places. So this is about 2.6 megajoules per kilogram. So much energy is what I need to actually convert 1 kilogram of water into steam. This was the amount of energy I needed to just convert the 51 grams into steam. So this is what I found from my experiment. The real value is actually 2.26 megajoules. So this is not bad. It's actually quite close to the true value. Okay, thanks for watching.